Hello everyone, in last video we have seen the classification of mechanical brakes, and in this one we will be studying the design or analysis of block brakes in detail. So it consists of a rigid block of frictional material which is attached to the lever and that can be moved about this fulcrum point to make contact with this rotating drum so that the kinetic energy possessed by the rotating drum can be converted into heat energy, or its speed can be reduced with the help of this friction that is generated at the friction surface by making contact with this one. For that you can apply force at the end of the lever, and you have to calculate the forces that can be applied to make contact, and what are the normal force which are generated, and what are the tangential forces, frictional forces developed, and we will be finding all of these parameters while designing or analyzing the block brakes. So here in the design of block brake, here you can see some of terminologies. So this is the figure showing when the block is making contact with the rotating drum so that the energy can be absorbed. So this is showing the frictional contacting surface, and along this one the force transfer between these two will be happening so that frictional contact will be made. So this is the line along which the tangential frictional force is acting, and normal to that this normal force will be acting between these two elements, and this contact is made with the help of the lever which is turning about this point which is known as pivot point or fulcrum, and that is happening by applying a force of F. So this F will be the external force applied, and in all our equations we will be using the tangential frictional force will be represented by Ft, and normal force will be represented by Fn, and you are having the relation the tangential force is equal to mu times the normal force Fn. So you are having the line of action of normal and tangential force, and here if you are calculating the frictional torque you are having, so frictional torque will be created by the tangential frictional force which is equal to Ft into radius, where radius is the distance from this one up to this surface, that is the radius of the drum. And here we'll be using some angle, that is the angle made by the frictional surface at the center of this rotating drum, and this angle will be called as 2 theta. So in the design of brakes, usually if 2 theta is lesser than 60, then all the equations are fine. Otherwise, we'll have to apply some correction factor. So in cases where 2 theta is greater than 60, then we'll be correcting the coefficient of friction mu to mu dash. Those kind of steps will be discussed when we are discussing a problem of such case. So these are the parameters, or these are the representations that we require for solving the problem. So Fn is the normal force, Ft is the tangential frictional force, capital F is the external force applied at the end of the lever to make contact. And here we will be classifying or studying the different cases based on the positions of some axis. So I will be showing you three axes, one which is right now I am drawing the green color, that the axis of the drum, and another one you can consider an axis blue line which is passing through the pivot point, and another one is the red line which is passing through the frictional surface. So based on the position of these three lines you can have three cases, and we'll be discussing or analyzing all of these cases. And some distance I can represent the distance measured from this up to this point will be calling as the distance B, and the distance up to the applied force F, this distance will be calling as A, and this distance we'll be calling as C. So this is based on the relative positions of the different elements. So A, B, C are the distances. So we'll be making use of all of this one for analyzing the block brakes. So based on the positions of the axis of drum, that is shown by the green line, the tangential frictional force shown by the red line, and the line passing through the fulcrum, you can have three cases. In case 1, it is clear that this blue and red line are along the same level or along the same direction. That means the line passing through fulcrum and the line passing through the frictional surface are at the same level. And here in another case, in the second case, the line passing through the fulcrum, blue line, is coming in between this green and this red. And in the third one, the blue line is coming outside of this 2. So it is obvious, you can understand clearly from these representations. So these are the different cases of block brakes we have to analyze. So we'll be analyzing the first case. Analyzing means you have to draw the free body diagram and you have to calculate simply the frictional torque or the frictional force in relation to the applied force, and I will be showing all the equations at the end of data book also. So here suppose case 1 and sub case is the drum is rotating in the clockwise direction. That means drum is rotating in this clockwise direction. For this case, you have to construct the free body diagram and you have to formulate the equations. So the drum is rotating clockwise and the frictional contact is coming at this surface when this force is applied at the end of the lever, and the applied force I will be calling as this force is F, and two more forces are there, Ft and Fn. So here you have to obtain the direction of Ft, and that will be depending upon the direction of rotation. And you know that Ft is the frictional force which is actually opposite to the direction of motion. So if you are observing here, the drum is rotating in clockwise direction, so motion is towards this in this direction left. So at this frictional contact surface, the frictional force will be opposite to the motion. So for this rotating drum element, you can represent the tangential frictional force in this direction and the normal force will be coming in this direction. So this is Fn, but we are drawing the free body diagram, or we need the free body diagram of this lever because the F external force is applied on this lever. So you will have to transfer this Fn and Ft onto this rigid block element where frictional contact is made. So the frictional force at this interface will be opposite to those things that we have drawn for the rotating drum. So Ft will be coming here and Fn will be coming here. And this is the case 1a where this fulcrum and the frictional surface are at the same level. So the other two distances are, this is B and this distance is A, and here since these are at the same level, C equal to 0. And now you can form the equations. So the same force I can show here. This is F, so this is Fn, and if you are observing the force Ft which I am drawing at this interface is actually corresponding to the free body diagram of the lever. So in simply you can take it like this, that if the drum is rotating in this direction, so in this same direction the motion is coming, so opposite to this tangential frictional force will be coming, so opposite to that the frictional force will be coming on the block. That means this direction can be directly taken to this case also. That means if it is rotating clockwise, then the frictional force will be on the lever will be in this direction. So now you can take the moments created by these forces about this fulcrum. So this Ft is creating no moment such it is passing through this point. So Fn is creating a moment of F clockwise moment Fn into B, and F is creating an anti-clockwise moment of F into the total distance A plus B. So I can write the clockwise and anti-clockwise moment. So clockwise moment is Fn into B, which is equal to the anti-clockwise moment of F into A plus B. So here I will be representing all in terms of the tangential force and the applied force F. So you are having the tangential force Ft is equal to mu times Fn, or Fn is equal to Ft divided by mu. So you can represent this Fn as Ft divided by mu into B equal to F into A plus B. So from this one you can write the expression for the external force applied F, which is equal to the tangential force Ft into B divided by mu into A plus B. So this is the expression that we are having, or I can write it as this F is equal to Ft into B divided by A plus B into 1 by mu. So this is the expression that you are getting. So in a similar way you can find the tangential force in terms of F. So Ft is equal to F into A plus B into mu divided by B. So in a similar way also you can represent. If Ft you are knowing, then you can calculate the frictional torque by knowing this radius of this drum. Then the frictional torque will be equal to Ft into R. So in this way you can calculate the frictional torque. So this is the way how you have to construct the free body diagram and arrive at this equation. So this same equation I will be showing in the data book page also at the end of this video. So this is the case where the line passing through the fulcrum and the frictional surface are at the same level, and also the drum is rotating in the clockwise direction. Next we will be seeing the case where drum is rotating in the anti-clockwise direction. So this is the second case where drum is rotating in the anti-clockwise direction. So if you are observing, this is the direction of motion. So at this frictional surface, the tangential frictional force should be opposite to the direction of motion. So in this direction will be coming, but we require the free body diagram of lever onto which the block is attached. So the tangential force will be coming in this direction and the normal force will be coming in this direction. Here pivot line is passing through this tangential frictional force line, and the distance is the same diagram, and I am drawing here also. So this is the actually this forces are for this lever element. So here also you can take the moment about the fulcrum, then the clockwise moment will be equal to F into B, which is equal to anti-clockwise moment of, sorry, this is actually Fn, normal force, Fn into B, which is equal to force F into A plus B. So this is the same equation that you obtained for the previous case also. That means if your pivot line and the frictional for conducting line or the line of frictional force are at the same level, then whatever be the direction of rotation of the drum, either clockwise or anti-clockwise, you will be getting the same expression for the force. Then you can arrive at an expression that you obtained in the previous case, F, which is equal to Ft into B divided by A plus B into 1 by mu. The same expression you obtained in the previous case also. So this is the way you have to draw the free body diagrams, and you can easily arrive at this one. So in a similar way, we will be discussing the other two cases with those sub cases of clockwise and anti-clockwise rotation now. So this is the second case where the pivot line and the frictional lines or the contact surface lines are at different levels. Here if you are observing, this is the pivot line which is coming in between the line of axis and the line passing through this frictional force. Here the direction of rotation I am taking it as clockwise. So for the drum, the direction of rotation is in this way, and for the drum the frictional force will be coming in this direction, but for the block the frictional force will be coming in this direction. That means whatever be the direction of rotation for the block of brake, you can take the direction of frictional force like this. So this is the tangential frictional force Ft, and normal force Fn will be coming in this one, and the force to be applied for engaging the brake F will be coming like this, and all the distances I can mark. This is the distance C about this fulcrum and this tangential force, and this is the distance B, and up to this applied force, this is A. So here I will be calculating the clockwise and anti-clockwise moment. If you are observing or taking the moment about the fulcrum, then this Fn is creating a clockwise moment of Fn into B. This F is creating an anti-clockwise moment of F into A plus B, and this Ft is creating a clockwise moment of Ft into this distance C. So I can take the clockwise moments on one side, then this is equal to Fn into B clockwise plus Ft into C clockwise. This is equal to anti-clockwise moment of F into A plus B. So here I will be representing this Fn in terms of Ft, which is equal to Ft divided by mu. So I can write Ft into B by mu plus C, which is equal to F into A plus B. So I can write F as F, which is equal to Ft into, so from here B I will be taking common outside of this bracket, then you will be having Ft into B into 1 by mu plus C by B. You will be getting the same expression I will be showing in the data book also, divided by A plus B you will be getting. So this is the expression based on the free body diagram of this case. And in this equation you can write the expression for Ft also. Ft is equal to F into A plus B divided by B into 1 by mu plus C by B. So this Ft can be used for evaluating the frictional torque, which is Ft into R. So anyway, if you are knowing how to draw the free body diagram, then you can easily arrive at this final expression. So in a similar way, we will be quickly going through the other cases also. We will be seeing only the final equations. So here in the anti-clockwise rotation of the drum, you can draw the or complete the free body diagram like this, and you will be getting the final expression like this. So with the reference to the previous one, here one plus sign was coming in the previous one, but here it is 1 by mu minus C by B. So this is the one. You can try yourself for getting this expression. So this is the one for the third case where the location of the pivot is coming in this direction. That means if this is the axis and this is the frictional surface, then the line passing through pivot is coming here. And this is for the clockwise direction of rotation of the drum. So frictional force on the block of material will be coming like this. Normal force is this one, applied force is this one, and this C distance B and A. So then you will be getting this expression like this. So if you are observing, for this arrangement, for the clockwise rotation, equation is like this. But for the second case, this was the same similar expression that you obtained for the anti-clockwise rotation. So here it is clockwise. And in the last case, your drum is rotating in the anti-clockwise direction, and you can draw the free body diagram like this, and you can arrive at this one. So if you are knowing how to draw the free body diagram, then you can simply write these expressions easily. Anyway, all these cases are given, as well as the final expressions are given in your data book in the page number 267, which I am showing here. So these are the first case where in whatever direction it is rotating, when the pivot line and the friction line are coming in same direction, the equation is same. The other case equations are given, the distances, all the parameters are also given. So learn just to draw the free body diagram. Remaining equations you can formulate yourself. If you are knowing this, then you can solve any problem from this design of block brakes. So the problem we will be seeing in the next video. So thanks for watching.